In this video, we're going to continue our discussion about consumer choice, and we're going to figure out how to use that utility function and indifference curves in combination with prices and income to figure out the consumer's optimal bundle. So to do that, we need prices and income, and that is where the budget constraint comes in. So the budget constraint is going to show us all combinations that are affordable. It's looking at the cost, price of both activities or both goods compared to the budget of the consumer. So this is given current prices and current income. And if either of those things change, you're going to end up with a different budget line. So over here on this graph, we see points D and point E and a red line connecting them. Point D means we're spending all of our money on skiing, and point E means we're spending all of our money on horseback riding. And then the line connecting them shows all the combinations in between using that full budget. Now, this does not tell us the prices or the budget. I have a graph on the next slide that will do that, but we're just going to assume that this represents the maximum they can afford. This is similar to the production possibility curve, but it's for consumption options. So rather than being like the maximum they can produce, it's going to be the maximum they can consume with their current set of resources, which in this case is income and prices. So anything on the line is considered efficient because it's using up the full budget. Now, in real life, you do not want to use your full budget all the time. Saving is a good thing. However, when we're doing some of these examples for our class, we're going to assume there's no benefit from saving, there's no utility, you only get happiness from consumption, and money doesn't have value outside of being spent. So we're going to say you're going to have the most utility, the most happiness if you spend the full budget, but in real life, please save for retirement. Inside the line, so any points in this darker shaded triangle, these are all affordable. These are all attainable combinations, but they're just inefficient. They're not spending the full budget. So this consumer could get more utility if they spent more, if they, picked a combination on the line instead. And then anything outside the line is unattainable with the current budget and prices. So if consumer income goes up, we can see this line shifting outward. Or if prices go down, we also could see that line shifting outward. So those affordable, attainable combinations can change depending on what's happening with budgets and prices. The opposite can happen as well. So we could have a decrease in income or an increase in prices that's going to shift that line inward. And this line and that darker shaded triangle, this is called the opportunity set. It represents all possible affordable combinations. All right, so let's look at an example. So here we have our budget constraint, and this is determined by the prices of two goods and the income or budget of the consumer. So in this case, we have a budget of $30, and they can buy coffee or donuts or combination in between. The price of coffee is $5, and the price of donuts is $2. So point A up here, hitting our donut axis, this shows using our full budget on donuts. So we have $30, donuts are $2 each, we can purchase 15 donuts. Point B down here represents using the full budget on coffee. So we can buy 6 coffees at $5 each. That's going to use our full budget of $30. So both of those points are going to represent spending all of our money on either donuts or all of our money on coffee. And then connecting the line between, see if I could do this without looking terrible. Give myself a C+. Pretend that's a straight line in between. This shows all combinations of donuts and coffee that cost full $30. And then the shaded triangle shows all possible affordable combinations that cost less than $30. So it's going to be less than the full budget anywhere inside this triangle. Anywhere on the line is going to be full $30. Okay. So all points on the line, it doesn't matter which combination you pick, any point on that line, whether it's A, B, something in the middle, C, D, these are all efficient and potentially all optimal points. So when we're trying to maximize utility, we're going to find our best combination somewhere on that line. Now, sometimes in real life, we're going to have to make choices over time. Like, for instance, you can't buy a quarter of a donut, right? You have to buy full donuts. And let's say this person wanted to buy 5 coffees. So 5 coffee is going to be $25. And then they have $5 left, but they can only buy 2 donuts at that combo, which is $4, which is $29. So technically this is like slightly inside the line, but maybe what they would do next week is they would buy 5 coffees and 3 donuts because they have that extra dollar left over. So if you're, taking this over a long period of time, we may see slightly, unequal or inconsistent consumption over the weeks because you can't buy, a fraction of a coffee or a fraction of a donut, and just depending on how prices work. So anything inside that line is attainable, it is affordable, but it's inefficient. Anything on the line uses the full budget and it is efficient. Now, not every point on the line is optimal. So you have lots of efficient options, but only one optimum combination. So one optimum choice, utility maximizing choice. And for that, we need to add our indifference curves onto our graph. So we need to put the budget constraint together with the indifference curves to figure out what that best level of consumption is. So we want to find that best choice, that optimal bundle for consumers. We are going to be putting the budget constraint together with the indifference curves, which are the utility functions, to figure out how our consumers can choose that best bundle. So we're picking best bundle that they can afford. And in this case, when we say best bundle, we're looking at something that's affordable, so it needs to be on or inside that budget line, with the highest possible total utility. Okay, so we're going to use marginal utility in a couple slides to figure out that optimal bundle, but we're really trying to maximize that total. And so we do have diminishing marginal utility, so the next unit's just going to give you a little bit less, so that, next bite of cake will make you a little bit less happy than the first bite, but still extra happy. So you want to keep eating that cake until it's hit 0, stop before it turns negative. So even if it's, less happiness than the one before, it's still adding to that total, it's still increasing it. So we're trying to maximize that total utility given our budget and prices. And our highest utility curve is going to be tangent to our budget line. And in that case, that's going to be this point right here. And tangent means it's just touching it at one point. So the utility function is going to touch the budget line at one point, and that's going to be your highest utility curve. The other ones, the inside curves, the ones that have less utility, are actually going to cross over that budget line. So anytime you have a utility curve that's going through the budget line, it's not going to be the best choice. There's going to be some higher one you can get to that's just barely touching it at one point. There will only be one best affordable bundle. So we're going to have lots of affordable bundles. Bundle means combination. So in this graph, we have food deliveries and streaming subscriptions. So the best affordable bundle is, in this case, 6 food deliveries and 1 streaming subscription, right? So it's the best combination. There's only going to be one. There's only going to be one with that highest total, and everything else is going to have less total utility. Okay, so how we find that on a graph is you just look and you see which utility function is tangent to the line. So 55, U50, U70, you can have lots of them, you can have a couple. We're just looking for that one that's just barely touching it. So in this case, that's going to be utility of 60. We can get a maximum of 60 utility with this current income and set of prices. You can also see there's higher utility available, 75, 100, right? You can just keep going out. This consumer, this example, it's just not affordable. 60 is the highest utility they can afford. All right, now we're going to look at how to calculate this using a table, and we are going to use a rational spending rule. This is going to help us determine how much of each item should be purchased. It is based on individual preferences, so the best combination for me is not going to be the same as the best combination for you. It is based on relative prices. So as prices change, it can actually cause us to buy less of something, more of something else. It just depends on the shape of those utility curves. And it is limited by the budget or the income. So our utility maximizing rule says that we are going to allocate spending so that the marginal utility of the last dollar is the same for each good, which means we are going to figure out basically marginal utility per dollar and if we're buying donuts and coffee, we want the last dollar spent on donuts to have the same marginal utility just for that $1, right? So marginal utility per dollar as the marginal utility on that last dollar of coffee. So basically your last bite of donut and your last sip of coffee are giving you that same amount of happiness per dollar. Okay. How we do this is we're going to take the marginal utility of one good divided by its price, and we want to find where that is equal to the marginal utility of the other good divided by its price. So marginal utility of good X divided by price of X should equal the marginal utility of Y divided by the price of Y. And if these are not equal, it usually means that you're not maximizing utility. Because if you just shift a little bit more money over to the one with the higher marginal utility per dollar, you'll be doing a little bit better. So it means you're overspending or underspending. So we were going to use this rule to find the best combination. And the goal, remember the goal is that we're trying to get the highest total utility. We're just going to use the marginal utility per dollar to help us find that point. And depending on the situation, sometimes it's easier just to calculate all the total utilities and pick the highest one. But when we see examples where we have changing budgets and changing prices, it's going to be much easier if we have this marginal utility per dollar. It's going to help us locate that point a lot faster. So step one, we're going to have a table, and it's going to tell us the quantity of each good and the total utility of each good. And then our first step is that we want to calculate the marginal utility for each quantity, which if you remember back when we did like marginal benefit, marginal cost, this is the extra between the totals. So how much extra utility do we get when we go from total 1 to total 2? Step 2, we're going to take each marginal utility that we found and we're going to divide it by the price of the good. So we'll do that for both X and Y. Then we want to locate or choose all of the quantities of both goods where that marginal utility per dollar is the same, or marginal utility divided by the price is the same. And then we want to check to see which bundles are affordable. So we may find 2 or 3 different options, and we just want to make sure that the one we found is affordable. Especially like on a homework problem or a test question, you'll probably find multiple matching sets, and then you have to pick like which one matches this budget. All right, so let's do an example. So we are going to assume that Joe consumes coffee and pastries each week, and he has a budget of $9. Coffee is going to cost $3 per cup, and pastries are going to be $2 each. Using the table below, determine the optimal bundle of coffee and pastries each week. So I'll do coffee, and then we're going to pause, and you're going to work on the pastry side and see if you can figure out the optimal bundle, and then we'll come back and work on it together. So coffee per week. So sometimes you'll see our table start at 0 or 1. Maybe if the table starts at 3, I think we saw one example like that. So marginal utility, if it starts at 0 or 1, we know what the marginal utility is. So 0 is 0, 1 is going to be 12. Or on this side, our marginal utility is going to be 5, right? Because it's just the extra between nothing and 1. And then, but if we started at 3 for some reason, like if this table just said like 3, 4, 5, 6, we aren't going to actually know what that marginal utility for that third one is if we don't know the total of the one before. So if it starts at 0 or 1, you can fill out that first chunk. Otherwise, we just don't know. Okay, so the marginal utility for the second coffee, our total is going to be 21, and our total of the first one is 12. So we're doing 21 minus 12, and that's going to equal 9. And then the marginal utility of the third one, we're doing 27 minus 21, and that's going to give us 6. And then we want to do marginal utility of coffee divided by the price of coffee. So our coffee is $3. We're going to divide each of these by 3. So first cup of coffee, 12 divided by 3 is giving us 4 utility per dollar. Oops. The second cup of coffee, 9 divided by 3 gives us 3 utility per dollar. And that last one, we're getting an extra 6 utility. So we're only getting 2 more utility per dollar, 6 divided by 3. Okay, pause the video here and work on the pastries side. So calculate the marginal utility of pastries divided by the price of pastries and see if you can figure out where they match and see if you can find that affordable bundle. All right, I'm gonna pause your video now. I'm gonna wait like 2 or 3 seconds and then I'll go over the answers. All right, so hopefully you filled in this other side. So let's go over it. Okay, so 2 pastries. So 15, we want to minus the total of 1, which is 5. It's going to give us 10 extra utility. The next one, 23 minus 15. It's going to give us an extra utility of 8. And then for number 4, we get 28 minus 23. Gives us an extra utility of 5. Now we want to divide that by the price, and the price of pastries is $2. So 5 divided by 2. Going to give us 2.5. 10 divided by 2 gives us 5. 8 divided by 2 is 4. And then 5 divided by 2 is 2.5 also. Oops. Okay. So that was step 1 and 2. Step 3, we want to find where these bundles match. Okay, so I see a utility of 4, a utility of 4. Looks like those are our only 2 that match. So now we want to check to see if that's a bundle we can afford. So this bundle is where we have 1 coffee and 3 pastries. So we want to make sure that this is using up our total budget of 9. So in this case, 1 coffee is $3 plus 3 times 2 is 6. That gives us a total of $9. Okay, so this is going to be our optimal bundle. This is going to give us the highest total utility. So in this case, our total utility is going to be, let me erase all this other stuff really quick. Oh, leave that there. Okay, so we care about total utility. So from our coffee, we're getting 12 total utility. And from our 3 pastries, we are getting 23 total utility. So this means our total utility for this bundle is 35. 35. And if we looked at all of the affordable combinations, we would see that we can't get a higher number than this. So other combinations that he can afford would be 4 pastries and then 0 coffee. This is going to give him total utility of 28. He could afford 3 coffees and 0 pastries. This would give him a total utility of 27. He could afford 2 coffees, 6 and 1 pastry. So 2 coffee plus 1 pastries. 2 coffees would be 21, and then 1 pastry would be 5, so that would be 26. So you could go through and figure out all the combinations that are affordable and see like what's the total utility, and then you pick the one that has the highest. Okay. So if you're not sure how I did that, what I did is I said if he's buying 4 pastries, total utility is 28, or 2 coffees and 1 pastry. 2 coffee gives him 21 and 1 pastry gives him 5. So it's adding the total utility for those different combinations. And so we used that marginal utility per dollar rule to locate this affordable combination a lot easier. Otherwise, you have to figure out like, okay, what are all the different ones they can afford? If he buys 1 more coffee or 1 more pastry, how does that affect the other side? And then if income changes or prices change, you have to start that whole process over again. So this is a good thing you could do to check it when you're trying to learn it, but using that marginal utility per dollar rule will help you locate that combination a lot faster. And then some of this it helps us explain like the income and substitution effects, which we talked about a little bit earlier when we were discussing demand. And basically, this helps us understand that when prices change, the optimal bundle of goods will also change. So if the price of coffee or price of donuts change, you're going to buy more or less. It's not always more of one thing. Sometimes it's less of the other thing. Sometimes it's more of both. It just depends on what's going on. And so the substitution effect says that price changes makes other goods relatively cheaper or more expensive. And especially when we're looking at that utility per dollar, because maybe, 1 coffee makes you happier than 1 pastry, like was the case on the example before. I think the first coffee gave him a happiness of 12, and that first pastry only gave him a happiness of 5, which means he likes 1 coffee more than he likes 1 pastry. However, when you're looking at that utility per dollar, he might actually be getting more utility per dollar from pastries, which is why you see that he ends up buying 3 of them, even though he might get more utility from coffee. So we're going to take that highest one first. That's why combination is usually better, because usually the first or second item has the highest total utility, and then it drops from there. But the price changes make the other goods seem relatively cheaper or more expensive, and it makes that utility per dollar different as well. And so we see people buying more SUVs in the 90s and less in 2004, and that has to do with price changes in gas. Not just the vehicle, but, substitutes and complements, other things that they're purchasing at the same time. And then the income effect doesn't have to do with your changing income. It has to do with how much stuff the income can buy. So price changes make us relatively richer or poorer. So if you're like, okay, is $10,000 a year a good salary? Well, it just depends on how much stuff costs. So in 2025, in 2050, right, those things, $10,000 is probably not going to be enough money. But if you go back 100 years, 500 years, right, like $10,000 might be way more money. So when people used to get paid $2 an hour, $10,000 is a lot different than when you're getting paid $20 an hour. So price changes make us relatively richer or poorer. If prices go down, that budget constraint is going to shift outward, meaning we can afford more stuff. If prices go up, it's going to shift inward, meaning we can afford less stuff. So increased gas prices make us relatively poorer, especially if you need to keep buying the same amount of gas. It means you're going to buy less of other stuff. Okay, we are going to end our lecture here. There's going to be some more topic pages and other things for you to engage with in the Canvas shell. So please read over that stuff, do those activities. Let me know if you have any questions. Have a great day.